Okay, so in order to do composition of trig functions, we need the trig functions. What we need here. This trig is from numbers to numbers. Okay, so not angle. Okay, so if we have a trig is converting numbers to numbers, then we may be able to define compositions, because composition of trig function would be just numbers to numbers to numbers. Okay, and this also will help us in defining this, computing these quantities. If alpha is just number plus h is number, apply trig functions, you get numbers also. So this difference of numbers and divide by numbers. Okay, so this will be defined. Then we can define compositions and quantity such that like this difference divided by h. Okay, so we need to convert angle to numbers. So from here, angles to, we can convert back and forth to numbers. Okay, so how we do this one? Well, we do this one by, all right. Okay, so suppose you have a say a tire circle. Okay, say rest at 0, and you rotate the tire. Okay, this rotate the tire and see how it right. So rotate the tire. Oops. Okay, keep rotating it. Let's see. At some point, the 0 here becomes up, something up here. Okay, and then you turn it again, and it becomes here again. Okay, and notice that at what values this one is. So this is a circle. I would say just unit circle. Unit circle. Okay. And when you rotate circle, something like this, and so it becomes here, you rotate. This is an angle alpha. Okay. All right, so this is what we need to find. When you turn this one, this becomes at this point. So say this is M, is now the M is this. So what is this this point over here? So this is ends back to this one. Okay. Okay. So what's the distance between 0 and this point here? 0 to this point. Well, while you rotate them, so it goes to here and is here. Okay. So distance would be 1/2 of the circumference of the circle. Okay. So 1/2 of the circumference of the circle is what is the 1/2 the circumference of the circle? Just one. One half of circumference. Okay, so what is the circumference of the circle? So the unit circle. What is circumference? Hello.
2 pi r
What is r?
radius.
Radius. So radius 1 here. So what you get here? There. So this is just 1/2. Here's the point, is just 2 pi. Okay. So that's the how our conversion goes. Okay, so here from 0 to, see, for n turn sorry, for n turning to this one is 180 degrees. So this angle, turning angle. So you convert turning angle of a unit circle to distance. That is part of the circumference. Circumference. Okay, so what we need to 0 degrees converts to 0. It doesn't move, right? So 180 degrees converts to pi, right? 380 degrees converts uh, to pi. Okay, so these are numbers, angles to numbers. So in general, alpha would be okay. All right, so this conversions is what we call the radian. Okay, so this is, let's see. Uh, a number here would x. Okay, so this conversion. So here we have x equals 0 converts to 0 times radian. So this is, so x equals pi. So 3.1415 and etc. Okay, so from here we get, so 1 radian. Well, pi is a number, right? And on the right hand side we have angles in degrees. Okay, so radian must be angle in degrees. So 1 radian is that divides by pi. So it's let's see. So 1 radian is 57 degrees plus something here. Okay, some minutes, some seconds. All right. So now we redefine our trig functions. So we call the sine. Oh, let x be a real number. What we call sine x is actually sine of, sorry, x, right? Okay, so x, right? Remember, this is an angle. Okay, so and similarly, cosine x means cosines of x radial. So it's because it's radial angle, radial angle. Radial angle. Why radial angle? That's turning angle. Okay, so that's the story behind why we have a how we define trig in calculus. Okay, so similarly we have a tangent. X is just sine over cosine. Okay, and we have also what we call the secant. Secant x, this is 1 over cosine. Cosecant of x, 1 over sine, and cotangent of x, which is 1 over tangent. So the reciprocal of the trig function, sine, cosine, tangent. Okay. All right. So conceptually, our trig is this calculus trig. So you x is a real number, and you get real numbers also. All right. So this is what go. Trig is this calculus trig, not triangular trig. But in computing the trig value, pretend, just pretend it is the the triangular trig. Okay, so conceptually we use our calculus trig, but when you compute, let's go back to the triangular trig with angles. Okay, and you'll remember that your calculator works can work also in radian or in angle. Okay, remember that one. Okay, so in the calculator you have radian, right, front, and angle, or in degree. That's in your triangular trig. And this is your calculus trig. Okay, so you can switch back and forth. Okay, so in general, we'll use this calculus trig. So all the notations in calculus trig. Okay, and you have the identities are all the same, except that um, uh, the x and y are just real numbers. Okay, you have the same identities as we do with triangular trig. Okay. All right, so we won't go back to that thing. Let's see. Now, what about the graph? Now, as numbers, 0 is not the same as pi. Right? It's not the same as 4 pi. It's not the same as, sorry, not the same as pi. So you won't have these situations anymore. Which situations? That cylinder thing. Okay. Why we have cylinder? Well, because somehow you identify this 180, or sorry, this 360 with 0. So these 3 points are the same: 0, 360, 720, 1080 are the same points. Okay, because you identify them, you glue them together, just glue. This point is just because you glue together, you get a cylinder. But as numbers, as numbers, 0, 2 pi, 4 pi, 6 pi are not the same. Okay, so we have like this. So this is pi, sorry, 2 pi, 3 pi, 4 pi. So if we have this one to the left, and we have, okay, and why the value cannot exceed -1 outside this range, -1 and 1. Well, because hypotenuse is always longer than 2 of the other sides. Okay, so the ratio must be less than 1, maximum 1. So have this. Okay, so this one becomes sine x. All right. So you cannot identify 2 pi, 4 pi, 0 anymore. Okay, so we have this. This is a function that we call a periodic functions of period 2 pi. Why? Because if you add, subtract, you still get the same thing. This is what we call a periodic of period 2 pi. So a function of the trig functions, sine, cosine, this is periodic of period 2 pi. What about tangent? Well, what about tangent? That's a sine over cosine. That's we deal with something that's slightly because cosine can be 0. Okay, so remember we didn't go from the beginning. See. So we would have later on asymptotes. Okay, there. Okay. There. Okay, so this is tangent. Let's do. See, this is 2 pi. Sorry, this is pi. This is pi over 2. Right. Pi over 2 pi. This is 2. Okay. So this is periodic also. So, but the period is not pi, but sorry, not 2 pi, but pi. All right. So this is what we have. And let's see. Let's just draw this sine and cosine. Okay, if this sine and cosine here is just this is cosine. This is the red one is sine. Okay. So then what you see is that okay. Question is, how do you get the red one from the green one? Just doing transformations. This is pi over 2. 3 pi over 2. This is 2 pi. How do you get the red one from the green one? just doing operations. See, what is that there? By what distance here? So
Half of pi.
this is distance. Okay, so pi over 2 half. Okay, so that means the red one so the sine you get from cosine by translate to the right by pi over 2. Okay, so that means by just observing this, okay, so here cosine x, when you translate to the right, that means the x subtract, you get sine x, right? You can check. This is a uh, correct formula. Check. Sorry, I'll check this one. Okay, so that's because cosine x minus times cosine negative pi over 2 minus sine x sine minus pi over 2, right? Okay, cosine pi over 2 minus over 2. Cosine, that's 0. Okay, so here sine minus 0, that's negative pi over 2. Sine is negative 1. Okay, so you get become sine x. Okay, so here you get a formula just observing the graph. Okay, so what about the other way around? How you get cosine from sine? Just looking at the graph. Sorry. How you get cosine from sine?
By translating the
Translate to the left,
to the
right?
left. Yes.
So then you would get this formula. Sine x translate to the left, right? To the left, that means you get cosine. Okay, you can check also. You get this one. Okay, so you can get quite a few identities just looking, just doing transformations, translations, for example, or sine, cosine. Okay. All right. One more thing about this one is that now we haven't discussed about dilations. What about dilations? Dilations is this one's. Is given functions. Dilate x. So you get this one. Okay. Or you dilate y-axis. So what is dilate? Stretch. or compress. Okay. All right. So for example, here, if you y equals sine x, that means you have, okay. So in terms of trig functions, this is a nice description of a dilations factor. So sine kx. See, I'll show you later. This is 2 pi. When you try to graph this one, 2x, you get something like that same 2 pi, but instead you get something that looks like this one. I should show you how to use the math software to graph this one, but next time. Okay. So what's the difference here? Okay. And when you have sine 3x, for example, you get something like this is 2 pi, but you have instead this. Right? If you think the sine x is just a wave, okay? This is wave of what is the frequency here? Between 0 and 2 pi, you have a complete wave. Here you have 2 complete waves. You have 3 complete waves. Okay? So what is this 1, 2, 3 signify? So when you write sine of kx, what is this chi k in terms of waves?
The frequency?
Frequency. Okay. So in general, in physics, maybe later on, I don't know whether it's going to be this semester or next semester. It's physics 1 or 2, but you deal with this one. A sine, sometimes you call it omega x. What is A? Because it is amplitude. Right? This is frequency. Okay. So sine x means you have one waves, complete waves, between 0 and 2 pi. 2x means you have 2 complete waves, 3 complete waves. Okay, and what was this amplitude? Amplitude, this is A, this one, this amplitude. Okay, so how you read this one. And if you think this going there, how you get from here to here? Well, sort of you compress and think about you're holding say a spring like this, compressed or stretch. Sorry, I should spring. When you compress, this one when you compress, right? And sometimes you can, right? So you stretch. Okay. So depend. So you think from here to here, you compress. So instead of just one wave, then you have two waves. You have three waves. So here you compress. So that's dilations. Okay. And if you, this one you stretch, then you get the dilations also. Okay, so this dilations, X dilations. Okay. What about Y dilations? Y dilation is just what you do with this A amplitude. Because if you dilate the Y, right, you multiply by 2, for example. Then if you put the 2 here, you get 1/2. So X dilation has something to do with frequency. And Y dilations is also stretch and or compress, but with amplitude. Okay, so that's how you should understand about dilations in terms of stretching and compressing the graph. Okay. All right. Any questions?
I think no, sir.
All right. All right. Good. All right. I think the last one is back to our how you call it, estimations. You estimate using estimations using absolute value. This is an introduction to the next chapter also, next chapter of the limit measure. All right, so let's take a let's see. I need to share this one. Let's see, where is that thing? Functions. Okay, so these are the identities that we need. There isn't a lot. Let's use. Oh, I forgot to mention about this negative means you rotate, translate. Okay, so this is, let's see, which one I would show. All right, so problem 23, for example. Oh, sorry, this one. So suppose x is no more than 2, show this is less than 8. So let's say here how we can get this one. So anyway, I forgot how to copy this one. Oh, okay, so okay, so share. let's see, is this? If x is no more than 2, show that 2x squared plus 3x plus 2 over x squared plus 2 is no more than 8. Okay. So what we do here is that we estimate. Okay. All right. So this should be less than. Let's put this. Okay. Because this is larger. And to make this larger, make this smaller. Okay. All right. So then this is less than x is less than 2. Then this is 4. This is 3 times 2 is 2. And this is, let's see. Oh, sorry. Just make it something easy. This is just 2. Okay. So with this 2, this 1. So this becomes just 8. Okay. How we compute such a thing? Okay, I'll ask Kemal to explain about how to make this kind of estimations. It's rather different from what you did so far in calculus computing. We mostly work with this one, but nowadays we need to work with inequalities, and it's a bit change of habit. Okay, so I'll see you in the beginning of the tutorial later, and then you do some problem sessions, especially this kind of estimations. All right, I'll stop here and I'll see you then later. Okay, thank you. I'll stop the share and share the video, share the notes and the videos. Okay.